Relative motion analysis, topic 12.10. This is the last topic from chapter 12. Relative motion analysis using two particles translating axis. In absolute dependent motion analysis, two particles are physically connected, but when two particles are not physically connected and we would like to know the velocity and acceleration of one particle relative to another particle, then it is called relative motion analysis. For example, when in dogfight, one of the fighter plane pilot wants to know the position of the another fighter plane, then both of these planes are in motion. So calculating the velocity and acceleration of plane A relative to B is called relative motion analysis, and it can be written as velocity of A slash B. So this slash indicates relative word. So it's velocity of A relative to B because they both are in motion. So objective is understanding, translating frame of reference and applying that for calculation of relative motion analysis. Let's look at this hypothetical example that there are three people here. One person is sitting on a chair in a train. Second person is running inside train at 5 miles per hour in the positive x direction. And the train itself is traveling at 60 miles per hour. So what will be the speed of this person relative to someone sitting at a fixed reference point, which is, let's say, at the platform? So speed of this person relative to A is called 5 miles per hour. We can write this as velocity of A relative to B. Now this person sees velocity of A as 60 miles per hour because the person does not have any motion relative to train. So velocity of this person is same as the velocity of the train. So there is speed called VA. That means the velocity of B observed by the fixed reference point can be written as velocity of B is equal to velocity of A plus velocity of B plus velocity of A. Sorry, this should be velocity of B relative to A because B is this person. So velocity of B, absolute velocity of B is equal to velocity of A plus velocity of B relative to A. If you rearrange this equation, it can be written as VBA is equal to VB minus VA. So just moving this on the other side will change the sign to negative. And that's the equation for the relative velocity calculation. So the velocity of B relative to A is defined as velocity of B relative to A. B slash A can be written as velocity of B, and then easy way to remember that is to change this like slash sign to negative and just write VA. So V numerator, then change this to negative minus denominator. Okay, so the correct answer is A. Since two-dimension vector addition forms a triangle, there can be at most blank unknowns, either magnitudes and or directions of the vectors. Okay, so there can be up to two unknowns. Now, few practical applications: that a person throwing a ball from a balcony and the ball is in motion with some velocity vc, and another person at A has to run at a different speed to catch the ball. So the speed of the ball relative to this person is known as velocity of B observed by A, or relative to A. Another more practical application is when fighter jets take off or land on an aircraft carrier, the velocity of the carrier becomes an issue because the carrier itself is in motion and the plane is in motion. So at that time, pilots need to know what is the velocity of the carrier, and they adjust the velocity of the plane so that when the plane lands and it stops, it does not have any velocity relative to the carrier. Before we talk about velocity, the first step is we need to talk about position, because position, the derivative of the position is called velocity. So let's define the concept of the relative position. So we have fixed observer, which is O. That means this person does not move. We have another observer which is traveling relative to O, or it's moving. So this is called translating observer, and his position is defined relative to O as RA. So vector RA is the position of A relative to absolute point O. And then there is another particle here which is traveling to this curved path, and the absolute velocity of that particle relative to, sorry, the absolute position of that particle relative to O can be written as vector RB. So that means this is the absolute position of A, this is absolute position of the B. What is the position of B relative to A can be obtained by completing this triangle here, and this is written as RB slash A. So RB slash A is RB minus RA. So if we each, for let's say for example, if RB is given by this vector using ij coordinates, RA is given by this vector using ij coordinates, then RB slash A can be calculated by subtracting values of A from B. So it's 10 minus 4 is 6, and 2 minus 5 is minus 3j. So this is how we calculate the relative position. And the derivative of position becomes velocity. So for velocity also it forms a triangle, that velocity of A, this is velocity of B, and this is fixed point. Then this arrow indicates velocity of B relative to A. And this can be written as this formula, or you can rearrange then write it as VB equal to VA plus VB relative to A. And same applies to acceleration. We can calculate the acceleration in the same way, and acceleration of B relative to A can also be written as acceleration of B. Then instead of slash, it's negative acceleration of A. So remember this formula. And now the next step to solve the problem, what we need to do first is we need to set up the coordinate system. We need to calculate each velocity as a Cartesian vector and then apply the relative velocity equation and solve the problem. Oftentimes we also need to draw a graph and apply the trigonometry such as law of sines and law of cosines to calculate the missing parameters. For example, this slide is very important because it explains the law of sines and cosine. So for law of sine, let's consider this triangle, and the length of each side of the triangle are A, B, and C respectively. Now, in terms of vector, the length indicates the magnitude of the vector, and the angle of triangle opposite to side A is capital A, opposite to side B is capital B, and opposite to side C is capital C. So these are three angles and three lengths of a triangle. So law of sine states that length of this side A divided by sine of the opposite angle is same as B divided by sine of the opposite angle is same as C divided by sine of the opposite angle. That means we can group this into any two equations ratios together, and if we know three parameters such as we know small b, we know capital B, and we know small c, then we can calculate the fourth one. Or we can also combine it like this, or we can also combine first and the last part together. So if we know two parameters out of three in the given ratio of four parameters, then we can calculate the fourth one. And law of cosine states that a square is equal to b square plus c square minus 2b multiplied by c and cosine of angle between b and c, which is cosine of a. So if we know b, if we know c, and if we know this angle a, then we can calculate this side a using this formula. Same also applies to side b and side c. So depending on the problem, we may have to use one of these concepts. Remember, see here that like this is a triangle, for example, and if we know this angle, let's say if we know this angle theta 1, theta 2, but we do not know this angle, then we can apply either law of sine or law of cosine and calculate those missing parameters. Okay, so that's it for the theoretical portion. We will now do problem solving in the next video. Thank you.